Hey, pre-cal students, want to go over the review questions. We've got a test coming up. 4 topics on the test: solving trig equations, using the Pythag and tan identities, using the double angle identities, and knowing about the 3 reciprocal functions. All right, so in the review, I have it divided up into sections. So the first part is going to be the trig equations. Remember what you're going to do here. You're going to solve for cosine or sine or tangent, get it by itself. And then you're going to look on your circle. There we go. We'll run through this kind of fast here. You're going to add 1 to both sides, divide by 2. You'll be able to do that pretty easily in your head. Add 1, divide by 2. Cosine x equals 1/2. That's step 1. Get the cosine by itself. I'm going to box that in. I'm going to look on my circle. We'll look on the old unit circle right here. And I want to find out where cosine equals 1/2. We know cosine is the first number. So I'm going to look on here. When I get to a 1/2, I'm going to write that down. And then I know that there's another angle right below there where cosine is equal to 1/2. So my 2 solutions are pi thirds, 5 pi thirds. End of story. Next problem. Pi thirds, 5 pi thirds. And that is our solution set for cosine. All right, next one. Sine x, 2 sine x plus square root of 2 equals 0. You're going to subtract 2 from both sides, subtract square root of 2 from both sides, then divide by 2. So after you do your little Texas 2 step, you get this. Subtract square root of 2, divide by 2, you get this. Let's box that in. We're going to look on our circle to find out the angles. Remember, x is the angle where you get that ratio. So here's our chart again. Sine is equal to the square root of 2 over 2 negative in the bottom quadrants. So we're going to look at over here and again over here. So one is kind of hard for y'all to see, but it'd be at 5 pi fourths and 7 pi fourths. What do we say? 5 pi fourths and 7 pi fourths. Just using your unit circle. Remember, sine is the second number. Sine is the second number. All right, moving right along here. Let's see. Move that up. For tangent, same thing. We're going to get the tangent by itself. We're going to add 1, divide by square root of 3. Now, for tangent, let me just draw the new circle here real quickly. So at this ordered pair over here, you're going to see that you have a square root of 3 over 2 and a 1/2. By the way, I included another copy of the unit circle in the folder, but it's always there in one of the folders. If you don't have one, go back and load that up. So anyway, if you look at that very first position, remember tangent is the second number over the first. So your second number over the first, if you cancel out those 2's, which you can do each and every time, you get 1 over square root of 3. That's what you're looking for. You're looking for a tangent of 1 over square root of 3. So if you look at this particular angle, this angle is pi 6. And that is one of your solutions. We know that there are usually more than one. So the other one, tangent answers are going to be diagonal to each other. So the other answer is over here at 7 pi 6. At this ordered pair, by the way, you get a negative square root of 3 over 2 and a negative 1/2. But the 2 negatives cancel each other out, and again, the 2's cancel each other out. So you're back to having 1 over the square root of 3, which is what you're looking for. Okay, the next 3 problems are squared functions. Remember, we had a couple lessons about that. On a square function, you want to do the same thing. You want to get the function, the squared function by itself. But when you finish this off, you're going to take the square root plus or minus square root, which is going to generate more solutions. So we get sine x equals plus or minus square root of 1. We know the square root of 1 is 1. Everybody knows that. So sine is equal to plus or minus 1. That's going to happen somewhere around here, one of those four places where you get your zeros and ones and negative ones. If you look carefully, sine is equal to 1 up here at pi halves. It's also equal to a negative 1 down here at 3 pi halves. So those are your two solutions here. X equals pi halves or 3 pi halves. So these are your, running into the problem, this is your solution to number 4. X equals pi halves or 3 pi halves. For number 5, let's do this one in purple here. You're going to do a Texas two-step. You're going to add 1 to both sides, which makes this one disappear, and then makes a positive 1 up here over here, and then divide by 4. You're going to root both sides. You're going to root this, you're going to root this, plus or minus. All right, so you root away the square. Square root of 1 is 1. Square root of 4 is 2. Remember, you can break this up into square root of 1 over square root of 4. And it's still plus or minus. And so we have, we're going to look to find out where cosine is equal to plus or minus 1/2. So that's going to lead us to our answers. Cosine equals 1/2 up here. There's one place where cosine equals 1/2. We call that 5/3. There's a place over here where it's equal to a negative 1/2. All of these thirds are going to be your answers. So if this one over here, your cosine is negative 1/2. This one over here, your cosine is positive 1/2. And if this ordered pair over here, your cosine is negative 1/2. We're looking for either a positive or a negative 1/2. So all of those positions that have a pi third involved in them are going to be your solution. 1 pi third, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Generally on these squared functions, you're going to get more solutions. Remember, cosine is the first number. You're trying to find what angle, at what angle does that first number come out to be a positive 1/2 or a negative 1/2. So what happens here, pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. All right, let's look at number 6. Tangent problem here. Break this up a little larger. We'll just deal with it here. All right, let me erase all this other stuff. All right, so for number 6, tan squared x minus 3. So the first thing we're going to do is we're going to subtract 3, add 3 to both sides. And then we're going to square root both sides. So now what we have is this. So we have tan by itself on the left-hand side. And we have plus or minus square root of 3. So we're going to look on our circle. So if you look up here at this ordered pair, you get 1/2 square root of 3 over 2. All right, and that's at the pi thirds. So if you think about the tangent here, the tangent would be the second number divided by the first. Cover up the 2's because they're going to cancel out each and every time. And so you get square root of 3 over 1. So boom, there's one of my solutions. All right, we also know that tangent answers are diagonal to each other. So there's another answer down here. That would be at 4 pi thirds. But if you look at these other ones, because we're looking for a plus or a minus, this ordered pair over here is a negative 1/2 square root of 3 over 2. And so if I calculate the tangent here, I cover up the 2's, they cancel out when I do the division. I get square root of 3 over negative 1, which is the same as a negative square root of 3. So I need to count this position, which is 2 pi thirds. By the way, these answers down here don't have to be in order. Like I went 1, 4, 2. And this one over here is another place, that's going to be 5. On these squared functions, all your denominators come out to be the same. All these are thirds. 1 pi third, 4 pi thirds, 2 pi thirds, 5 pi thirds. And those are your solutions for this here. So besides these problems, go back and look at some of the other notes that we did, some of the quizzes and videos that I had posted last week. All right, let's move on to the next topic. So the next topic is using the Pythagorean identity. Cosine squared plus sine squared equals 1. And then sometimes you have to use the tangent one also. So I included both those rules for you. So when you take the test in a couple of days, make sure you have all your formulas handy. What you're going to do is write down the rule. So if they give you cosine, want you to find sine, go ahead and write down the rule. Cosine squared plus sine squared equals 1. They tell you cosine is 3/5. So you can put it 3/5, but you have to square it. That's what that power 2 means there. 3/5 squared is 9 over 25. So you're going to subtract 9/25 from both sides. All right, you can do this on a calculator, but you can also do it easily without a calculator. If I have one basket full of 25 candies, one basket full of 25 candies, and I take out 9 candies, how many candies am I going to have left? 16 candies, 16 out of the 25. I had 25 out of 25, subtracted 9 out of 25, and I get 16 out of 25. Again, you can do it on a calculator if you like. All right, so now you're going to square root both sides, and you get sine x equals 4 over 5. Square root of 16 is 4. Square root of 25 is 5. I need to figure out what my plus or minus signs are. In quadrant 4 looks like this here. Everything's positive here. This is negative positive. This is negative negative. This is the positive negative quadrant, cosine and sine. So if I'm in quadrant 4, I want to make sure my answer is negative for sine. Remember, when you take the square root here, normally you put plus or minus, but in this particular case, it has to be only the negative answer. In quadrant 4, sine is negative. Sine is like a y value. So that's what you got to do. You got to watch for the plus or minus signs on these. All right, another similar problem. This time they want you to find cosine, but write down the rule. There's the rule. You know sine this time. You do not know cosine. You know sine is 1/4. 1/4 squared is 16. Subtract 1/16 from both sides. So I had a bowl of Halloween candy. There were 16 total in the bowl. I took out 1/16. That means I'm going to have 15 out of the 16 left over. So now I have 15 out of 16. I had one whole bowl full of candy. I took out 1/16. Now I only have 15 16s left. I'm going to root both sides. Root. Remember, root undoes the power 2. So I get square root of 15 over square root of 16. Square root of 16 is a 4. And do I want a positive or negative in quadrant 2? Quadrant 2 is my negative positive quadrant, so cosine is negative. I want a negative answer in the story. Cosine equals negative square root of 15 over 4. 15 there. All right, let's do one we had to find the tangent, which is going to involve a little bit of extra work here. All right, before you can find tangent, you have to know the cosine. We know the sine, but we don't yet know the cosine. So we're going to use both rules this time. Pythagorean rule and the tan rule. It tells us that tan is 1/2, negative 1/2, but it doesn't matter if it's positive or negative, it's going to square away anyhow. All right, so negative 1/2 squared, negative 1 to the negative 1 is a positive 1, 2 times 2 is 4. The negative squares away. So I'm going to subtract 1/4 from both sides. I have one whole pizza, I ate 1/4 of it, I have 3/4 of it left. So I have cosine squared equals 3/4. I had one whole pizza, I ate 1/4 of it, I have 3/4 left. I'm going to root both sides. So I get cosine x equals square root of 3 over the square root of 4. But the square root of 4 comes out looking like a 2. I'm in quadrant 3. Sine and cosine are both negative in quadrant 3. Now that's not my final answer, because I want to find tangent. Tangent, remember that rule I showed you earlier, tangent is the sine over the cosine. So I'm going to come off to the side here. The sine was given to us at negative 1/2. The cosine we just calculated is negative square root of 3 over 2. So we get a fraction over fraction, but unfortunately on this one, we don't need to worry about flipping it over and multiply. You could flip that 2 upside down, it would cancel there. But you can actually cancel the 2's right here. And so you get negative 1 over negative square root of 3. Negative 1's the negatives cancel out, and you get 1 divided by square root of 3. By the way, you can also do that 1 on the unit circle. If you look on there and find out where sine is negative 1/2 in quadrant 3, sine is negative 1/2. Let's see, second number right here. And the cosine would be negative square root of 3 over 2. Divide those out, 1 over square root of 3. You can't always do that, but sometimes you can. Moving right along here. Double angle rules. And all these formulas are given to you. So you want to choose one of these formulas that helps you solve the problem. Now, in order to find, first thing you do is write down the rule. If you're going to find sine of 2x, you have to write down this rule here. Now, we know the value of cosine is given to us at 5/12. But the problem is we don't know what sine is. So we got a big old question mark here. What you're going to have to do here is double work. You have to go back and do the same thing we did before, just now, to find the cosine, the sine that goes with that. In other words, you're going to have to go back and use this rule real quickly. But we're getting pretty fast at this, aren't we? Cosine equals 5/12. Let's see. So we don't know what sine is. 5/12 squared is 25 over 144. Come back over here. So subtracting that from both sides, save a little bit of time because the video will cut off if I go too long here. I get 1 minus 25 over 144. Again, you can do that on your calculator if you want. Think about the 19. Yeah. An ugly number here, 119 over 144. So when you do 1 minus 25, you'll get 1 minus 25, 144, you get 119 over 144. And then when you root both sides, again, this is a very hard one here. You're going to get square root of 119. The square root of 144 is 12. Ooh, it's a lot of work. And what you're going to do with that result is you're going to plug it in here. Fortunately, there's only going to be one like this on the test. This is a very hard one. 119 over 12. I didn't mean for these numbers to be so ugly. I think the numbers on the test work out to be a lot nicer. All right, so to finish this off, you multiply all the numbers on top, the 2 times the 119 times the 5, well, that'll be 10. That'll be 1190, and then 12 times 12 is 144. And you don't have to reduce that. You can if you want, because they're both divisible by 2. You don't have to reduce that. So that's kind of an ugly problem there. But one of the tests will be nicer because you'll have easier numbers to work with. But the process is going to be the same. On the sine 2x rule, you have to go and find the other piece. They'll give you one piece. You need to find the other piece from the Pythag. Fortunately, these other ones are going to be easy because you don't need two pieces. For the cosine of 2x, you don't need two pieces. All you need is one or the other. So here we go, cosine of 2x. Now there are 3 rules. We're going to choose a rule that saves us trouble. There's one rule that involves only cosine. Back it up to that rule sheet. This rule here, 2 cosine squared x minus 1 is what we're going to use. Because that one saves us a lot of trouble. 2 cosine squared x minus 1. So here's the rule we're going to use. We're trying to find cosine 2x. We know that cosine is 2/5 here. Don't forget we have to square it as well. So we can do the rest of the calculator if you want to. Without a calculator, 2/5 squared is 4 over 25. So we get 8 over 25. Now these you will sometimes get a negative number. So this is going to be the opposite of 1 minus 8 over 25, which would be 17, I believe. Negative 17. Yeah, on the double angle one, it's very common that you'll get a negative answer here. All right, so again, that's a lot easier than number 10. Same thing on number 12 here. On number 12, if you want to find cosine of 2x, there's an easy rule to use. Cosine 2x, one of the rules says here, 1 minus 2 sine squared x is one of the rules. I'm going to choose this one because they're telling me sine. So I don't have to find any other piece. All right, so sine x is 3/5. I'm going to square that quantity. 3/5 squared is 9 25ths. All right, so I have 9 25ths times 2 is 18. So I have 1 minus 18 out of 25. I had a bowl full of 25 pieces of candy. I ate 18 of those pieces of candy. How many do I have left? I have 7 out of the original 25. So cosine 2x rules are easy. Sine of 2x is hard. You got to do extra work on that. All right, moving right along here. Reciprocal identities. These are kind of easy. Basically, you're just finding a flip of one of the main ones. Cosecant is a flip. Secant is a flip of cosine. Cosecant is a flip of sine, and cotangent is a flip of tangent. So this is a super easy one. They want you to find cotangent when they tell you tangent. Well, all we're going to do is flip it upside down. Now, if you follow the rule strictly, the rule says this here. 1 over something really just means a flip. But if you actually go through the process, you'll see why it flips it over. Remember in algebra, you divide by a fraction, don't add y, flip the bottom and multiply. Keep it, change it, flip it. So when you flip this, guess what? You're going to get 1 times 5/3, aren't you? Now, you don't need to do this each time. I know that's what the rule says. It says 1 over the other function. Just flip it. 1 over something means flip. 1 over something means flip. So just flip that number. You don't have to do all this at all. Just take that number and flip it. Number 14. Secant, remember, secant is the flip of cosine. So we have to find cosine of 2 pi thirds. We did that several weeks ago, almost a month ago, using our unit circle. So on our circle, we're going to find, look over here, 2 pi thirds. 2 pi thirds is up here. The cosine over here is negative 1/2. Cosine's that first number. So that first number, we're going to flip it. The flip of negative 1/2. The flip of negative 1/2 is going to be negative 2. It's negative 2 over 1, which is negative 2. 15, cosecant, this equals the flip of sine. So we're going to flip the sine of pi halves. So we got to find on our circle again. So obviously you're going to need to have a circle handy. Pi halves is right up here. And the first number is 0. The second number is 1. So if you're going to flip that second number, 1 is already 1 over 1. So if you have a 1 over 1 and you flip it, well, guess what? You're still going to get 1 over 1, aren't you? So the flip of 1 over 1 is still going to be 1 over 1. So the answer here is cosecant pi halves equals 1. By the way, if you ever have to flip 0, you're going to get undefined. The flip of 0 is undefined because 0 is currently 0 or 1. So if you ever have to flip 0, you're going to get 1 over 0, and that's going to be undefined. That doesn't happen here, but it might happen on the test. If they want you to flip 0, you're going to get an undefined answer. But the flip of 1 is going to be 1. The flip of negative 1 will also be 1. All right, I think this is our last one. Cosine is 2/7. Find the value of cosecant. So the hint here is that you have to find sine first. You have to remember that cosecant is the flip of sine. Cosecant is the flip of sine, so you need to find sine first. So go back to that all-important Pythagorean identity. It's the most important rule in this class, and it's very important in calculus as well. All right, so we know that cosine is 2/7. We're going to square that. That'll give us 4 over 49. I'm going to skip a step here. 4 over 49 subtracted from 1. So I have 49 candies in a jar. I took out 4 out of the 49. Then I have 45 out of the 49 left to give to the trick-or-treaters. All right, so then we come over here and we root both sides. We're going to root this. We're going to root this, plus or minus. So we get sine x equals square root of 45. I don't know what the heck that is. Square root of 49. I know it. Everybody knows that's 7. And then I didn't give a quadrant. Let's assume quadrant 1. I should have given you a quadrant on this one here. Let's say it's quadrant 1. So that's why I'll make sure I do that. So it would say like in quadrant 1. So it'll be a positive value. So we want to find the value of 10. Cosecant is going to be the flip of this here. So the flip of that would be 7 over square root of 45. Cosecant is simply the flip of sine. So again, going back to those rules, 1 over something means flip. Secant is the flip of cosine. Cosecant is the flip of sine. Cotangent is the flip of tangent. Just find the original function and then flip it. All right, that's it. Go back and rework these problems, and then we have the test coming up tomorrow.